Good morning, everybody. We'll present the OPENCOSS project. I guess we presented for some of you some of the material we will show you now. But the idea is that if you have any question about the, not only about the usage, but also about the implementation of the OPENCOSS tools, this is an opportunity to discuss it, okay? Since we would like to use some of the work done in OPENCOSS, it is important to understand how it is done, what is the status of these tools, etc. Okay. Okay. In the first slot, we will present a general overview, and I will go quickly on some of the slides, which most of you already know. Just a second. Okay, OPENCOSS was a project of 17 partners. In addition to these 17 partners, there were 21 external advisory board members. It's important to get benefit of this external advisory board. So some of these were proposed in AMASS to still become part of this external advisory board. And some of the people that were there were, for instance, people from NASA. Michael was the name? John Knight from University of Virginia. Some people from Toyota, etc. And we did some meetings where we get some useful feedback from them. Okay. Okay. Some of these goals will be presented in detail during the telco. We have 5 technical objectives. One of these was related to the common certification language. So I will present a little bit about this idea, this Metamodel from OPENCOSS. But in addition to this, there were objectives regarding compositional assurance and certification, evidence management, about supporting the process of not only assurance but also about the engineering process. Okay, and we created some scenarios of usage of these tools. Okay, I will present these industrial usage scenarios in the next slides, just to say that in the middle of this usage scenarios, you can see system assurance and certification project activities. So this is the core of activities of OPENCOSS, and we wanted to connect these activities with other activities from engineering, from requirements management, design, validation, verification, quality management. There were 2 tangible results from the project. One was conceptual, which was the CCL language, which is open and is available in the OPENCOSS website, and also all the methodologies around the use of these concept ideas. Okay. In addition to this, the other tangible result was the tools. So we released this in open source, and we are in the process of getting part of PolarSys community, as you know. Okay. So starting from the first objective, this is what I will explain now because it's the core of the project, and the other technical objectives will be presented in the other technical slots. Okay. So the idea of CCL was, first of all, to have a conceptual basis to specify various concepts for assurance and certification. Okay. From all the concepts which are coming from industrial standards, but also any other concept that is used can be used by companies to manage the process of assurance and certification. Okay. So, but in addition to provide this conceptual basis, we wanted to do it structured. So it means that it should be easy to search the information, to store the information in an ambiguous way. Okay, and also another goal of CCL is to factorize the concepts from various application domains, from various sectors. So CCL is factorizing these concepts, but also CCL to instantiate this concept for a specific application domains. Okay, so why we need this CCL is to facilitate reuse from projects, from project to project. This could be from the same domain, from different domains, etc. So one of the goals was to reuse all the activities done in assurance and certification. The second goal was to understand in a common way and to interpret the information that is exchanged between various actors. Okay, and finally we wanted to automate some labor-intensive assurance and certification activities. So this was the rationale behind CCL. Okay, this complex diagram is just to explain that what we have behind this CCL metamodel. So the metamodel, or what we call here the conceptual level, is the set of concepts that are used for assurance and certification. So we grouped those concepts in related groups. So for instance, any information about argumentation is stored in a set of package, metamodel package. Evidence management is other set of package. Compliance management, which also cover process management, is specified in another metamodel package. But also we have the way to map concepts, and what we call mapping here is a way to mapping concepts either for equivalence between various standards or application domains, but also we use the concept of mappings to map what is required by the standard and what is done by each of the assurance projects. So it's a kind of compliance mapping. Okay, so these are the concepts, and in addition to this, we have some support for specified vocabulary by using SBVR standard from OMG. By using this metamodel or conceptual level, we instantiate two levels here. One is to model standards, but also to model specific process from companies, process which could follow the standards, but in some cases could have more specific information. Okay. This level is used as a guidance to help companies to comply with the standards. Also to summarize what are the requirements that are used by those standards. Okay, the bottom level here is another instantiation of the metamodel, but it is used to create a specific project. So in the middle you have models that are created from the metamodels, but which are project independent. So it means that these models can be used in various projects by one company or by various companies. Okay, but below we have a specific project-dependent information, which could be any information about the assets that are used as evidence to demonstrate compliance, any information about the arguments, and also about the process execution and assessment of the assurance process. Okay, so in addition to this, we have an instantiation of the vocabulary. So the vocabulary will be explained in the argumentation slot and how it is used. Okay. So very quickly, this is just to say that this conceptual model will be has been instantiated, and this instantiation is our data model for the OPENCOSS tool platform. So some concepts are specific for some of the functionalities, like for instance, all about argumentations will be reused and will be instantiated by those tools. That there are some common concepts that can be instantiated in various kind of tools. For instance, the concept of evidence or artifacts is used in two kinds of tools. Okay. Very quickly, some concepts about the implementation. So all this metamodel, the CCL metamodel, has been used to create instantiation of the database of OPENCOSS tools. Okay, and the access to this database is done by using the CDO technology from Eclipse. So the idea from CDO is that we can use the EMF metamodels to automatically create the database. Okay, but in addition to create a database automatically from the metamodels, we need to adapt the tools or to access this server in the standards, means in the CCL and data structure. Okay, so we we use a Postgres SQL as our implementation. It's a database, but we can use any, I think, other kind of technologies for the database. So we have two kinds of clients that access this database. Some clients are Eclipse, so tools based on EMF or other modeling plugins for Eclipse were used to access this database, but also we can have a web browser. So we created an OPENCOSS server for the web clients, and some functionalities which are intensively used by users that are not able to access to Eclipse, for instance, can get access by web. Okay, so this was a very key implementation decision in OPENCOSS, because our intention was to have something centralized, to have the old information updated online. So at the beginning we have a version based on files, but it was not sufficient to get coordinated access to this file. So this is why we migrated to a database approach. That's for the implementation. This is just another view, more detailed about the implementation. I will not go into details, but just to say that we have 3 levels, which is standards in this kind of applications. The user interface clients, so which can be Eclipse or web. The business logic level, so we have a set of functionalities. A set of functionalities grouped by the workbench we mentioned before. So some workbench are used for standards modeling. This is what we call reference framework specifications. Some parts are used for artifact or evidence characterization, traceability analysis, gap of analysis, not gap analysis, sorry. And other groups are for process specification and arguments management. Okay. So in addition to this, you can see here some APIs. We have two kinds of APIs. One for getting information about artifacts, or what we use as evidence. So this will be explained in the evidence management session. And we also have some APIs for process tools. So we did an implementation with one tool for process management, for workflow, and we can exchange information with this kind of tools. Okay. Okay, this is the diagram I showed before, but in more detail. So we have kind of set of activities in the middle, all about assurance. So activities for evidence management. So it means characterization of the evidence, evaluation of this evidence, and also link to the real repository or the tools which manage this evidence. Then we have tools for assurance case development, or what we call argumentation, for compliance management, and also for process management. Okay. The idea was to link this with engineering activities here in the product engineering project, and also to connect with other actors, like if a company is exchanging information with some suppliers, so they should be able to exchange this information in the same format as specified by CCL. And also independent safety assessors can also get information about these functions. Okay. Okay. I will go very quickly because all these activities or scenarios of usage will be explained in detail later. But what we call prescriptive knowledge management is all about the functionalities of modeling standards, rules, regulations, or also company process, and all this information can be modeled and introduced in OPENCOSS, either by using the specific user interface done by OPENCOSS, or also by exchanging data from process tools. In our implementation, we did an implementation with Atego Process Director to import information from the process. Okay. In addition to this, we can also model these equivalence mappings. So this is very specific. When we want to reuse information from one domain or from one project which is following a specific standard into another following another different standard, so we can model this equivalence, and this is also part of this prescriptive knowledge management. And all information can be then, which was stored, we can then access for various projects. So this is the kind of activities which can be reused in various projects. Okay. What we call here assurance project management is to create a specific project. So we need a bundle or a kind of perimeter to say, okay, all the information which is managed by this project or assurance project is related to a specific company certification process project. Okay, so the idea is to capture any information about this project, which can be what are the standards which must be complied, or what are the roles that will play people in this specific project will be captured here. Okay. What we call here baseline, defined safety assurance project baseline, The baseline in OPENCOSS is a model of the standards that is an excerpt of this model, which will be used by a specific assurance project. It means that when you develop any safety critical product, you don't need to follow all the requirements from a standard, but you can select a specific set of requirements, which could, in some cases, based on the criticality level, for instance. So in this step, we are able to instantiate this assurance, these standards models for a specific project, and to say, I will use this subset of requirements from a given standards, and we can also combine requirements from various standards. Okay, this functionality about permission was not implemented in OPENCOSS because of resource constraints. That is something we expect to implement in AMASS. Okay, then we have the flow for evidence from specified evidence, collect the evidence and characterize this evidence, to link to the real artifacts, to manage the traceability, and to do some analysis about the impact of changes on those evidence. We also have some functionalities for argumentation, from specify argumentation, but to structure this argumentation, and also in some cases to modularize this argumentation to enable reuse, and also to link those argumentation with the information we stored in the evidence management workbench. So any link to the evidence, the characterization of the evidence, and the real resource which represent the evidence can be linked from the argumentation part. Okay. In the same way as evidence management, we have the similar flow for process management, but in addition to what we have for artifact management or for evidence management, we have some metrics. We created some metrics to quantify some information about the assurance project. So information about the requirements which were complied, the requirements which missed, the number of claims. This kind of metrics were captured by the tools. Okay, this is the general presentation of OPENCOSS. If you want to see further information, you can see most of information. I think all the technical information is available on the website. There is also the manual to use the tools. The version for PolarSys is not open yet. We are working on it, but very soon you will be able to download and to test the OPENCOSS tools from OpenCert. We have demo videos and also some publications. I guess that not all the publications are open, but if you request us, we can send whatever of these publications. Okay. Okay. That's all for the first slot.
Yes, some question. So this is Stefano. Can we ask questions, or do you prefer to receive questions at the end?
I guess I think it's better to receive your questions now.
Okay, so I have some questions. So if you go back to slide 5, you have a general picture of the framework in which you listed a number of standards. I was wondering if all these standards are effectively supported, so the mapping already exists, or if I use one of these standards, I need some further work in order to instantiate the CCL vocabulary or other things that I have to do specific for this standard.
In OPENCOSS, we really didn't implement all those standards. We did some examples based on the demonstrators of the industrial case studies, but we modeled only some standards. In some cases, not all the standards modeled, because as you know, the standards are very huge. So we modeled the most important parts which was relevant for our case studies. One important thing, not only for OPENCOSS but for AMASS as well, is that we think that if this becomes reality in the industry, these tools, the creation of these models, the standards, will be per se a kind of business model. So companies that create interpretations which could be validated by some organizations about these standards could also sell those models. Right? We want to get open the tools, or most of the part of the tools for AMASS, but the libraries or specific information which are stored in the tools could be subject of business if some companies are open. So this basically because the effort to model those standards is huge.
But we we were able, at least for some part of the standards, we did try it with all of those ones, but the big part of modeling was just on the standards that were used on the case studies. However, to validate the CCL, we did some examples with them. I think it was all of them.
So, so a follow-up question is, suppose I have my project, my certification project, and a new standard that is not yet integrated in this framework. What is the cost of adopting the CCL vocabulary? That is, what is the cost of creating these mappings according to the experience that you had in OPENCOSS?
We think that the most important effort is for the conceptual work. It means you have a standard and you want to map all those concepts to the CCL concepts, right? So you need to make sure that those concepts can be modeled according to the CCL concepts. We really didn't quantify the efforts done. We did some estimations, which you can see in deliverable 1.5, the effort, but this was based on some extrapolations on excerpts of the modeling we did. But I agree the effort to do these interpretations and modeling can be important. But if we are able to create these models and then to some way certify or qualify these interpretations, so this should be available for many companies or for many projects. Can be reused in those various projects.
Yes, indeed. Seems reasonable also to improve the mapping that is done at the conceptual level can be used to improve also the standards. So another question, if I may. In the next slides, you showed the client server architecture. Yes, this one. Is the online connection necessary? So is it really necessary to connect to a remote server, or can the OPENCOSS platform be used standalone locally? And if not, what is the information that resides online compared to the information that is local? Just to have a brief idea of how the information is split between the server and the client. Was the question clear? Maybe I lost the connection. Can you still hear me?
I can.
Yes.
So did you hear my question? I'm not sure.
We did.
Was the question unclear?
Maybe we lost Huáscar, I don't know.
Yeah, maybe Huáscar is not. Huáscar, we cannot hear anything from you.
Hello?
Yes, now we can hear you.
Sorry, the Wi-Fi was down. Okay, I'm another computer. So you asked about the real need of having something centralized, right?
Yes, if it is necessary, or if the platform can be used standalone on a client without connecting, and if not, what is the information that resides online, or what is the information that instead can be kept locally?
Okay, we can of course work. We can of course. Sorry, there was another computer here. Okay, we can work locally if we create all this structure of Postgre, etc., in a local basis. So this is the more simple way. If you ask, and if we can work in a file way, in fact, our implementation can switch to a file storage way, but some small modification must be done. I think there are not really too much work, but we can switch to a file way to store all the information. We need, of course, the problem. We have, of course, the problem of synchronization. So we want to update something in a local place, and then we want to integrate this in another database or another place. This is not implemented. We cannot guarantee consistency when we import. We import the files. Okay.
Yes, yes. So for collaborative mode, it's necessary to have this client-server architecture, but conceptually is not necessary. So if I understand correctly, it would be possible in principle to support also just local based on files implementation.
Yeah.
Okay, thank you.
Something that we need to evaluate more carefully in AMASS is what kind of functionalities we target in AMASS are really needed to be connected online in companies. So this is something we need to ask users. There could be some functionalities, like for instance modeling and standard, which can be done offline, and then we can integrate it in a centralized database for further usage. But we need to take care of consolidation of information or synchronization of information. So we need to keep coherence when we integrate those external data in a centralized database.
Yeah, because I would expect that some users may have some requirements about the privacy of the data that is used in the certification, and maybe I would expect that some user may be interested in having everything localized.
Yeah, we also discussed this issue in OPENCOSS. Some partners like Thales were concerned with this, so we say that all the information which relate their real artifacts, design, whatever, should be highly securized. It shouldn't be open. There should be any possibility to get access to them because of this. They are sensitive. So we didn't work in this security concerns in OPENCOSS, but I guess that we want to have something usable, and for the safety critical domain, we need to work on this in AMASS.
Okay, thank you.
Okay, is there any other question?
Yes, this is
could you please
okay. Please. Stefano from Intex. Yes, there's a small question about. So I'd like to ask you if you investigated the possible link with between the CCL and the language provided by OMG for argumentation and evidence management, the SAC Metamodel.
So what is the question? Or what is the relation with the OMG standard?
Yes, if you investigated the relationship and between the.
Okay, yes. From the beginning, we worked in SACM, but when the project started, SACM was evolving. So we studied both, because the SACM has two parts. One for model argumentation, another for model evidence. So we worked in both parts. We found that the argumentation part was reliable, so we reused the argumentation part of SACM, and but we needed to extend some concepts, like for instance, all the concepts for modular argumentation were extended, but then these concepts were adopted in the future version and the next versions of SACM. Okay, this will be explained later by the argumentation slot. Then the other part of evidence, we found some limitations for this from this metamodel for the extensibility method. So, for instance, there were defined some evaluation properties for argumentation, which were fixed in the metamodel, but we didn't want to fix the evaluation properties for evidence. We did it more extensible. We can create any kind of property about confidence of this evidence in OPENCOSS. To do so, we were forced to create a new metamodel. So currently, SACM is evolving. I don't know what were the changes, but in summary, we are using the argumentation part, but the evidence part was not used. So we need to evaluate if the SACM now is better for the evidence part in the AMASS context, I mean.
Okay, thank you.
Could you please comment on the word evolutionary in the name of the project?
Sorry? Evolution?
If you could say why the word evolutionary was perceived important so that it made it to the name of the project.
Yeah. We saw at the beginning of the project that the practices in the certification activities assurance was very lineal, meaning that normally this work is done at the end of projects, and there was not really an incremental work on those assurance and certification activities. So there were in companies fragmentation between the engineering part, which was evolving in some way, and the assurance and certification part, which normally evolved in a separate way. So we wanted to have something which incrementally evolved during all the engineering project, from the kickoff project to create all the roles of the project, to start creating the structure of argumentation, the link to the repositories for evidence, etc., and incrementally evolve this information. So all the evolutionary side of OPENCOSS is reflected in the methodology and how all the assets from the project are managed incrementally or evolutionary.
Thank you.
Okay. If you don't have any other question, I will go to the next presentation. Sorry, I changed of computer. Can you hear me?
Yes, I can hear you.
Yes.
Okay, I will explain. I think I will go fast in this part because some of the parts were already explained before and we are delayed. So the compliance management, in our understanding in OPENCOSS, is any activity related to demonstrate compliance with industrial standards. Okay, so it's related to what the standards define and also how it is demonstrated. In OPENCOSS, the objective for this compliance management was, as I said before, to facilitate interpretation of the standards and also to exchange information, to discuss with the various users about this interpretation of the standards. It is also a common way to store this information in a structure to be retrieved, categorized, etc., and also for search and browse of the information. In addition to modeling standards, what we want to have is to provide a understanding on how the requirements would impact in the development process. What is the status at any moment of the compliance with the standards, and also how we can reuse from one domain to another, or from one standard to another, all the information done for demonstrate compliance. Okay. In our understanding, in our approach, we have a way to, first of all, model the standards, to model this standard in a structured way. And when we have this model in a structured way, we can use it for any actor that could inspect those standards, but also the process, the assurance process, and how is going the process regarding the compliance with the standards. So it could be to say that a document is not in the right place, that something that is missing, so it means any gap analysis of the compliance, if something must be qualified, or any specification that is missing. Okay. And also to say, okay, there are some techniques that are recommended for your process, and you need to follow according to the criticality. What are the steps you need to do in your process? Okay. In order to do so, we have our approach to the tools to store the models. So this view you can see here. It's just a conceptual view. It's nothing formal. It's just a conceptual to say we are using the CCL, and by using the CCL we can instantiate some models in our tools, and how these models are related. So in the top part here you can see some models which represent the information from standards. So this is what we call reference framework. You can see on top model reference framework model for the ISO 26262. So all the information from the standard is captured in this reference framework model. We can also have any other standard like DO178C model, and we can capture the equivalence between the various parts of these models. So between artifacts, between the activities, or between the requirements from those standards. So we capture this in what we call equivalence map model. There could be also some other kind of equivalence map model, and it's related to the relationship between standards and what the company follows. So for instance, Thales companies or Thales divisions have different process. Some of them are modeled in the same tool, and these process models can be done for railway or for avionics, are mapped to the standards in some way. So we can model how the process model for creating software for avionics, for instance, are mapped to the standards. We use for this the equivalence map model for those mappings. So as I said before, all this top part is something which is independent from the assurance projects. Okay, this can be reused in various assurance projects. And below you have an example of an assurance project, a concrete assurance project. For instance, one of the case study was the ePark project for the automotive domain. And if we have a perimeter for this assurance project, what we need to do first is to instantiate or to do the tailoring of this reference framework on what we call the baseline model. So we say, okay, I will use only some parts of the ISO 26262 standard for the ePark project, and we can select what are those parts and create this baseline model. So this is something automatic that is done in the tools. Just a question of select the parts that will apply from the standards, and then we can automatically create the baseline model. And this baseline model becomes what we call here what is planned to do. Okay, so this is the information that must be complied during the project. Okay. I have here an example of a standards model. So this is related to the first part of this prescriptive knowledge management. So we have the standards. So for instance, here a standard from a Senelec standard. I guess it's EN 126. I don't remember. And all these activities, which are detailed in the standards, are captured partially graphically in OPENCOSS and partially in forms and formularies. So in this case, we are showing some of the activities and sub-activities from these standards, what are the artifacts which are inputs and outputs, and also the roles or the profiles which are defined in these standards, which will work in those activities. Okay, some of this part is graphically captured, and the idea was to easily understand the structure of the standards. But we also have this information to be accessed in tree view or in forms. Okay, just for instance, here you have a tree view of these standards with the set of activities, and within an activity we can go to details of this activity and know a table of recommendation from the standard. So this table that you can see here, the technical measures which are defining the methods that can be used, should be used for the different criticality levels, are stored in a structured way in the OPENCOSS tools. Okay. In addition to this, what I mentioned before, that when we have the standard models, we can create the baseline models. Okay. So we can do it by using a wizard, and this wizard, at the end of the wizard, we can select the activities. In this case, ISO 26262 activities, artifacts, etc. are shown here. So we can select what are the ones that can apply for our project, and this will be instanced or tailored for our specific project. Okay. Then, when we finish this wizard, we will create not only the information in text, but also the information in graphical way to that show what are the parts of the standards that will be applied for our project. Okay. Okay, this was for the first part. The second part about the assurance project. So we assume that we created these baseline models. We can have various baseline models for the same project. So this is because in some cases, some project could need to comply not only with one standard, but also in some cases with two standards. So we need to create another baseline model, and both baseline models are part of the obligations for these projects that must be fulfilled to demonstrate compliance. So in the right part, you see the various models that are created in OPENCOSS. So we have three groups: argumentation models, artifact models, and process models. Of course, these models are connected by some meta classes, but these are the three groups that which are managed by different workbenches in OPENCOSS. In addition to this, we have what we call here a compliance map model. So it means how this assurance project is demonstrating compliance regarding what it was planned to do. So here we have in the left side what is planned to do, in the right side what has been done really in the project, all the information about the artifact use, the argumentation presented, the process execution. Okay. So if we go to the examples, which will be demonstrated in more detail in the next slide, here we have a model of the artifacts. So in a tree view, so we have information about the generic characterization of the artifact. So what are the nature, the type of the artifact, etc. We can also show the versions, the different versions, and people that modify the versions of the artifacts. We can also have properties about these artifacts, evaluation of results. So if someone wants to evaluate the artifact, so all this is traced here, and also any events changes of the artifacts are managed here. Okay. By using all this information, we can analyze the impact of the change of some artifacts, because the traceability is managed between the artifacts. Okay, this will be demonstrated in the next slide. Then, as I said, as you can see here below, the compliance map model is basically based on this assistant window here, where we have in the right side what has been done. So it means all the evidence used in a given project. In this case, this was for the railway project. We have the hazard log, safety assurance study for ramps, etc. All these artifacts are in the right side, and in the left side you have the obligation. So what is being required by the standards, and we can model here not only the link between the compliance, but also some justification to what extent the compliance has been done, if it is full, it's partial, what is missing, etc. Okay, this is the compliance map model. Then when we have all this information, which is what's done basically in Eclipse, we can, by using the web client, we can consult the information on compliance, but also we can modify from the web client any information, okay, according to the permissions. So here in this example, you have a summary of the compliance in a given project for ISO 26262, and the list of elements of compliance are listed here. So these are artifacts. The level of compliance, the status of the compliance, and also any detail and the link to the real artifacts or resources can be done from this interface. And finally, we can create Word or Word reports from these summaries, okay, at any time in the project. In addition to this, we can also summarize the gap, so what is missing to comply with the standards. So we can quantify here what are the aspects that are missing to comply and what are the parts that are missing. Finally, we can also get some metrics on the process. As I said before, we have a default set of metrics, but this could be extended. So metrics about the mappings, the baseline, the assurance assets, the standards, the process, the time efficiency in these cases, etc. And this helps to understand what is the progress in the project and what is missing during the project. Okay, this is the presentation for the compliance management. I added, and if you want to see the metamodel for one of the parts of the CCL, you can see, of course, all the details of these metamodels in the OPENCOSS deliverables. I think concretely this in deliverable 4.4, which are specified in metamodels. You can see here that this reference framework is capturing information about activities, roles, techniques, artifacts, requirements, etc. As was also done in SafeCer, we studied various process models to model this, but we found that there was some missing information in the process metamodels. This is why we created our own metamodel for this. So we have the concept of reference framework. We have what we call criticality level. We can create criticality level. So in some domains, the criticality level could be named seal, in other a seal, or or other names. So we can create any criticality level here and their relation to other information from the standards. Okay. This is the presentation for the compliance management. Do you have any question?
One question from Stefano, FBK. Is the report generated somehow, can it be tailored to the standard? Or is uniform for all? I mean, it's not aware of the standard.
You mean this Word report?
Yes, yes.
Yes, I don't remember which tools was used for creating reports, but the report can be customized. This is your question?
Yes, yes. I would expect that in general people would like to have a customized, a standard template that is used in particular standards to generate this report.
Yeah, I don't know the tool we used for creating reports, but as any other report management tool, we can modify the template, we can select the fields from the table that we want to show, the weight to show, the logos we want to show, etc. I am sure we can modify this, but I don't remember what was the tool.
But this is not a report, this is not a document, and therefore we don't have a template to generate this kind of report. This is a web page, a standard web page made with Badin technology to make that look and feel. And later, all this information is exported to a Word document, but not following any specific format that could be made by standardization companies or in a formal way. For that, we should customize, or we must make some work to generate some standard templates to generate standard reports following the templates standard templates.
Okay. He was Angel. Okay. Okay, is there any other question?
Yes, I have a question. It's Mario from CA. In the slide 4, you were talking about the tailoring. So is it the tailoring? Is it automatically done, or you have some assistance to help other people to select the path they want for the baseline? The slide 4.
This one, you mean?
The slide 4. 1, 2, 3, 4. Yes, this one. So the link between the reference framework model and the baseline. You are talking about the tailoring. So this tailoring is done automatically, or is a manual selection of the parts?
Yeah, this is what I show here. But when we are creating, this assurance project, we want to create an assurance project, ePark project, for instance. We will have a wizard at the beginning, and this wizard will ask us what are the information about the project, etc. At the end of the wizard, we can select a reference framework from a library, select the reference framework which the project will be based, and then we can select here what are the elements that will apply to a given assurance project. So it is not really completely automatic. We need to select, but then when we finish, all the model is created both graphically but also in the model way.
Okay.
This is the question?
So I have another question, yes, about the slide 9. Yes, so here where you are talking about the linking the artifact to the process. So this link is a real traceability link, so we can have the artifact model or element by itself, or it's just a link to notice that we have developed some artifact somewhere and it should be available.
I don't know if I understood very well your question, but the links or the traceability when we manage in OPENCOSS is only related to the information we manage in OPENCOSS. So it means that if the artifact is, for instance, a model from another tool, this must be modeled as here as a resource. So we create a resource, and we can link this artifact to the real object or the real resource, which is the artifact, right? So here we are not managing the link or the traceability between those artifacts, the real artifacts. It's only about the information we are dealing here in OPENCOSS. I don't know if this answers your question.
Yes, it was to know that if the link was some traceability permanent link that was maybe based on AMS, so we can validate that the model exists in real, and we can have the link to this model from the process. So if I understand, you just put the information that the artifact exists as a resource, and it has to be stored somewhere that we can find. It's not really linked directly as evidence within the process.
Yeah, it's not. We are not managing the traceability in the real artifacts with the information we manage. The traceability functionalities are very important, and we need to work a lot, I guess, in AMASS to improve these kind of things.
Okay, thank you. And I have a last question about in the slide 11 about the compliance. No, maybe it was 10 then. Yes,
this
so
one?
Here where we are, yes, this one. We are talking about the compliance and the justification. So this justification is manual, and the compliance is about the baseline we are creating is compliant to the reference framework, not exactly the execution of the process.
No. I don't know if I understood your question. This compliance map model can map various kinds of information from artifacts. So here we are filtering to show only the artifacts. Okay, but we can also show the compliance about process elements. So activities which are defined in standards and activities executed in the project. So if we filter here by activity or by role or whatever element from the process, we can see here the maps between what is being prescribed by the standard and what has been executed in the project.
Okay. Yes. So it's about the execution, the real execution. Okay. That was the answer I want. Thank you.
Okay. Thank you. Is there any other question? Okay. Thank you.
So the next presentation, it's about the part of the argumentation, about the safety cases. So I'm assuming you have some knowledge on safety cases. This is a requirement from the standards at the moment. On the automotive domain, the ISO expects that, well, they have a definition saying that you have to argument that the safety requirements from an item are complete and satisfied by evidence compiled from work products of the safety activities during the development. In avionics, there is also a requirement saying that the safety case or safety synthesis communicates a clear, comprehensive and defensive argument that the aircraft and the systems are acceptably safe to operate in a particular context. And in railway also it is requested this safety case. So it has been on the standard. It started for nuclear power, then goes for others, and now it's coming in. These were the three domains that we work in OPENCOSS, and as it was part of the requirement, we were also working on that, and it was one of the objectives of OPENCOSS to have a compositional certification approach, and the safety cases, well, assurance cases were providing us that option. When we thought about argumentation, we were always thinking on 3 dimensions. We need to argument about compliance. Compliance saying that we will focus on the standards and regulations. Also, at the same time, just because you are following a standard doesn't mean that it's safety. We also have safety arguments, safety or risk arguments, specifying how we have identified our risks, our hazards, and how we are mitigating them. But that is not enough. We also need to argue about how confident we are in those safety arguments. So all these arguments are linked. Most of the work till now was done on this part of the safety argument, in a modular way, trying to, because we are using modular, it was easier to understand it because you can classify it by topics. So this is something that similar. Where is argumentation for us? Well, we have an assurance project. In the assurance project, just as Huáscar has explained, we do have a baseline, but we also have this assurance package. This assurance package contains the information about the process, the artifact, and the argument. So we are part here on the assurance package, and we will argument about these three dimensions, about compliance of the standards, about the safety of the system, and how confident we are. This is how we actually have our standard. What it's here, well, we said it's kind of a vanilla flavor of the SACM. Why? Because we did use the part of argumentation of the SACM, and you will see some similarities here on the palette, because we use the naming of this SACM. However, for graphical notation, we did apply as GSM. And when we were doing this, we discovered at that time that SACM did not provide all the needs that we wanted, did not provide all the functionalities that we wanted. For example, it did not provide information for patterns. So we extended to include information about the patterns and more about modularity. Something that we didn't have was the contract, the argumentation contract. and so we include it. So we do have everything that SACM has, plus a bit more. And we do have a complete mapping between ESN and SACM. After we made this, we saw that in the industry, this naming of the standards was not much used, and it might be more interesting, at least in the palette, to have the ESN concept. But this is something that we would like to do it in AMASS. But at the moment, what we do have is behind it, we have SACM. And graphically, we have ESN. So let's focus on these different topics of arguments. For compliance, we have an automatic generation of the compliance argument. But we do model, we have a model transformation. So from information you have in the baseline, we transform it and to have just the part of compliance argument. What we do is we transform everything we define, it's an activity, it's a reference activity, we transform it into a claim. If we have a requirement that an activity should have some requirements associated, those requirements are claims, and they are subclaims of the big claim, which was the activity. When the standards talks about artifacts, about documents or work product, we transform it as a solution in ESN, as an evidence. And so if you classify activities and sub-activities, we will also put these claims, subclaims, and we will have an inference relationship between them. So with this, we just do the modeling. Oops. That looks a little like this. We do not link, this is something that in the end we have finished. We do not link the claims with the evidence, with the solutions. We put the solutions, but you have to make the link. So it's a way to ensure that you will do it, because we just put the information, but we do not link it with the actual document, because we did do this transformation at the beginning of your project when you create the assurance project. So for safety arguments and actually for confidence arguments, what we are doing, we're using patterns. We can use patterns for actually any aspect of the safety case. Most of the patterns that are in literature are related to safety arguments. We did create some patterns in OPENCOSS. Those patterns were more information based on what information we need for component-based certification. So we will have system-level arguments and component-level arguments. And basically what is this? We try to capture nice argument that has already been used and was good. It's the best practice. So there we can capture either company expertise or some certification approaches that were successful in the past, and we want to reuse this approach, or for tools. And it's really easy to apply this for OPENCOSS platform, because what we do have, we have a view in the tool where we store all the patterns and all the modules that you have in your computer, and we just have to drag and drop. When you choose one and drop it in your editor, it actually copies all this information and you just have it. Then you just have to do the instantiation and adapting to your specific case study. For composition, that was one of the main objectives of OPENCOSS. what we were thinking is, we were thinking of composition in a way that we have components and we have to integrate them in a system. So we will have some guarantees about properties or guarantees about the certification requirements, and we will have assumptions. All these will be stored in a contract-based approach. For actually explaining about the properties and how we are demonstrated that the value of a property, well, this is supported by vocabulary. And so let's see what we do with composition. One of the examples we have was the reuse of a silk. And what we defined was a way of allocating information about the project, the complete system, and a sub-project, which is the silk. In the system, we have information about how we validate the assumptions that we make in the silk sub-project, and how we actually have a good integration and that the reuse is feasible. And in the silk project, what we do have is information about, specifically about how it was created, this silk. So what we do have is, for example, assumptions that we made during the development of the silk in our arguments, in our safety cases, were identified as assumptions. But the information we have as guarantees in our argumentation editor, what we put that is those claims are public. When we have this, we are somehow making the context of this. So we have our arguments. In our arguments, we mark some concepts like, well, this is an assumption, this is a guarantee. And we have integration patterns, and we do have a wizard that help us do the link. So if we are integrating a system and a component, we will have information that we import from the argumentation of the system and the component. All the guarantees and assumptions on the context, for example, of the system, and the guarantees like the safety requirements and assumptions like the environment where it's going to be used of the component. And what we do is just link. So this assumption is linked with this guarantee, and if we need some kind of explanation, it will be linked. It will be associated with the integration pattern. So we do have that. And but actually, how this contract looks like another argument. For vocabulary, one of the problems that we saw on the argumentation is that, well, nothing prevents you from writing bad English inside those claims. So we wanted to have some support for vocabulary. So what we do have is you are able to have a vocabulary. So you will have your concept there. There are different ways to get this information. There has been some research about how to import it from the standards, but this was not tool supported. It's just a concept research. We did try it, making the vocabulary by ourselves. And once you have a vocabulary, you can use it on your arguments, because if you want information on a specific concept, it does provide you the meaning that is included in your vocabulary. So you can have a vocabulary, for example, for the ISO, and when you argument and you want to know, well, the component word, the component noun it's used in some wide ways, depending on the domain, on the person you talk to. So what is exactly going to mean here? And you get the information there. And the other thing is, oops. Doesn't give you information. The other thing is, well, how the claim is written. We also include some way to have structure expressions included. So depending on the type of the claim, we provide some suggestions on how it should be expressed. So this and for doing this, just for providing these suggestions, we just have to type Control plus space, and we'll provide you this information. And basically, this is the main things that we made from argumentation in OPENCOSS. Do you have any questions? No? Then we can move forward to the next presentation. I think for this, we need José Luis. You can make a presenter to José Luis. Oh, I can make it.
Can you see my screen?
Yes.
Yes.
Okay. Can you hear me? Okay, okay, I lost the sound for some time. Are you seeing now full screen?
Yes, but okay. Please talk a bit louder.
Yes, I will try because I'm having some problems with the sound. So I'm going to introduce what we did regarding evidence management in OPENCOSS, and I will try to be brief since we are a bit behind the schedule. So mostly what we did in OPENCOSS, where we provided support for managing the life cycle of what we call safety evidence. So I will first introduce some overall ideas and objectives that we targeted. I will then present the main concepts that we used in OPENCOSS and the tool support that we developed, and I will finally present some conclusions. Some of the aspects related to evidence management have already been presented.
Hello?
By...
We cannot hear you very well. It is only a problem from us, but or the others can also have problems.
Yes, it would be. You have to
Yes,
be a bit
difficult
louder.
to hear. Can you just try to speak closer to the mic?
Can you hear me better now?
Yes.
Okay, so I will try to, to speak closer. So as I was saying, I will introduce what we developed in OPENCOSS for managing the life cycle of safety evidence. So this mostly consists of several concepts that are integrated in the CCL and the tool support that we developed. So just to so that we all are on the same page, I will introduce these main concepts. So when we talk about safety evidence, we refer to artifacts. Okay, so these are artifacts that we use to make people develop confidence in the safety of a system, and we also use them to show the compliance with safety standards. So typical examples of safety evidence can be safety analysis results, specifications, testing results, or source code, for example. We also use the concept of chain of evidence. So with this, we refer to a set of pieces of evidence that are related. So for example, you have one requirement which is validated in some test cases, and the results from these test cases are recorded in some report. And finally, we have the real notion of evidence management that we use to refer to the area of assurance and certification that is concerned with the collection and handling of the body of safety evidence. So this includes both individual pieces of safety evidence and chains of evidence. Huáscar has already presented this figure. So as well as he has introduced, evidence management consists of several activities. So the first step is to determine the evidence to collect. This is part of what we call prescriptive knowledge management. And when you have determined what you have to collect as evidence, then you have to gather those artifacts. So you have to collect the artifact information, and you can also specify relationships between the artifacts, that is traceability, and also with other information sources such as argumentation or process information. And when there is some change in this body of evidence, you need to perform a change impact analysis. So I will also present a bit about the support that OPENCOSS provided for this area. As we have also seen, all the evidence management activities correspond to this area about what a project has done. And then we have to map this information, this artifact, to the baseline to indicate how we are complying with applicable standards. Evidence management in OPENCOSS is not an isolated area, but it relates to all the other main functional areas that we addressed. So as I have said in a couple of slides before, you have to indicate the evidence to collect with what we call prescriptive knowledge management. All this information about the artifacts is managed in the scope of a specific assurance project. We also need to record information about the process that has been followed in a project and how the artifacts has been used throughout the process. And we also need to use this evidence to support the arguments that we develop in a project. I'm now going to introduce the main concepts that we specified in CCL for managing evidence. So we have this first concept of artifact definition. So this is an abstract unit of data about some information that you need to manage in an assurance project. So for example, imagine in a project you need to record information about the hazard log. But then this hazard log, for example, will have several versions during the project, several individual and concrete units of data. So for representing these different versions, we use the notion of artifact. So at the end, the artifact definition would be like the collection of all the information about an artifact during its life cycle. And with artifact, we'll have the different instances of version of the artifact. for example, the hazard log after design or after V&B. For the artifacts, we can also indicate properties. So I typically use the example of a test case result, which can indicate that the test case has been passed or not. Resource, I think it relates to what Morayo has asked before. So with a resource, we indicate the place, which can be electronic or not, where the artifact is actually stored. So in OPENCOSS, we are not managing the artifact themselves, but we are managing information about the artifact. And this is information that someone would need for assurance or certification purposes. As we have already indicated, we can specify relationships between the artifacts to keep traceability between them. And we also realized that we need to keep information about the events of an artifact to keep a complete track of their life cycle, and also about the evaluations of the artifacts. So maybe, for example, someone reviews an artifact and indicates if the artifact is complete, consistent, or any other property that he or she needs to assess. Do you have any question about these concepts? So I will move on. These are now some what I call practical considerations about what we did in OPENCOSS. So I have already mentioned that in OPENCOSS we don't manage the artifacts themselves, but information about them. As we have seen for other areas in OPENCOSS, all these concepts that I have introduced are generic, because at the end we aim to support evidence management for several application domains and different companies. So it is true that when you go to, for example, automotive, they don't refer to artifacts, but maybe they refer to work products. But the notion, the common notion among different domains is what we call artifact. As I have also explained, the way we use artifact definitions is to keep track of the whole life cycle of a given artifact for a project. So we would have the artifact definition for hazard log, and then we would have specific artifacts for that artifact definition. And it can also be the case that we have an artifact type, like a requirement, and we need an artifact definition for each different instance of that type. So we might have different requirements in a project, system requirements, and we need an artifact definition for each of them so that we can keep track of their individual life cycles. And finally, an important aspect for evidence management is that we need to take into account that the variety of the artifacts can vary. So we can have a document that will correspond to an artifact, like a requirements specification, but we can also have what would typically be parts of a document, for example, a given requirement, which also corresponds to an artifact in OPENCOSS. And at the end, there is no overall rule for deciding the variety of an artifact, but this will depend on its purpose. For example, if you need to keep traceability between individual requirements and test cases, then you need to define individual artifact requirements, as artifacts. I will now start introducing the tool support, even though some of these aspects have already been presented by Huáscar. So as he has said, in OPENCOSS we develop two types of tools. We have Eclipse tools. They mostly correspond to editors of information, and a web tool, which mostly corresponds to reports about in this case, the evidence information. We had 5 functional areas. One was called evidence storage. Then we have traceability, evaluation, change impact analysis, and also integration with external tools. So we developed some functionality so that we could exchange information with tools where, for example, the artifacts are stored. Well, I will mostly focus now on the Eclipse editor. So I think that most of you have experience with this type of tools. So these editors are mostly form-based, and they are simple to use. So you have, for example, here the different areas of information for an artifact, the version, the properties, the evaluations, and the events. And then you have this properties view where you edit the information, like the relationships with other artifacts, or in this case the version that precedes the one we are using now. For impact analysis, we developed some basic functionality, and to this we developed a life cycle of the different states that an artifact can have in a project in relation to its state for impact analysis. So when you create an artifact, it's initially valid, okay, because you have only entered information. But then there is some change in the project, maybe something that relates to that artifact is modified, and that can impact the artifact. So typically, for example, if you imagine you have a safety case report, and it refers to a hazard log. So if the hazard log is modified, you might need to validate if the safety case is still suitable, or maybe you also know that you have to modify the safety case so that it remains valid. So this is the overall life cycle that we define for the artifacts regarding the state for change status. And finally, you don't have to revoke an artifact in a project because it's not valid anymore for safety assurance. So for instance, if I have a report with some test case results that validates a requirement, and that requirement changes or it's removed from the project, then those results are not valid anymore for certification. So I would have to revoke the results from a project. As I have said, we didn't manage this information about artifacts and information in isolation, but it also related to other areas. So Alejandra has introduced how we use artifacts as evidence in argumentation. And we also had this other view of a project, both its process and the activities performed, the people involved, the techniques used. So this is information about how the process of a project actually happened. And we can indicate, for example, what the artifacts were used as input and output and activity. Regarding the integration with external tools, we developed a mechanism so that we could indicate the resource of an artifact in an SVN repository. Then we could also open the files from Eclipse, for example, and keep track of how the actual artifact in the repository was evolving. And well, as some of you may know, we try to develop some mechanisms for integration based on OSLC, but we faced some challenges. So at the end, the solution was to develop an OSLC-like approach. So we call this OSLC-like because it's not fully OSLC, but it uses the same principles. So for example, we developed a REST API for integration with external tools. And the proof of concept of this integration mechanism was with Metamodels, which is a tool by KPIT, which, for example, performs some safety analysis activities like FTA. So these screenshots below correspond to this integration. So we could, for example, export and import information from Metamodels, and also with Artego Process Director. So this is a workflow tool, which is shown here. That is used in industry for following the process at a company according to a given standard. So what we did was to exchange information between the OPENCOSS platform and Artego Process Director. So you could import or export information from this tool in the OPENCOSS platform. So in this case, for example, we don't specify all the process information by hand in the platform, but we would import the information about the process in a Swans project from Artego Process Director. And this is my last slide, even though, well, if you want to check more information, there are some other slides with more details and the Metamodels, but I'm not going to present them because we don't have time today. So the overall idea about evidence management is that we need to keep track of the life cycle of the artifacts that we are going to use as safety evidence in a Swans project. Within this area, in OPENCOSS, we thought, or we argue that both traceability and impact analysis are essential areas for managing the evidence. The results that we created are generic, and they can be used or they can be tailored for company or project specific purposes. And finally, as you have seen, the tool support in OPENCOSS is somehow basic, because, well, you can specify the artifacts in a project and how they are evaluated, the traceability, the change impact analysis. Also, what Huáscar has shown, the compliance with the baseline, and we can also exchange information with other tools. So I think that even though this tool support might look basic, I think it's still very important and it's essential for our project. And somehow this is what should correspond to the basic building block in AMASS. And that's all from my side. So do you have any question?
And this is Stefano from Intec. Just a question. You talk about the OSLC, and you mentioned the fact that you encountered some issues. Can you please elaborate a little possible about that? So which kind of issues?
So I'm not an expert in OSLC, but I will try to answer. So for, there are two things there. One thing is that when we started to check OSLC, it was at a different status as it is now. So technology has evolved. But in any case, we found some issues, for example, regarding the granularity of the information that you exchange. So maybe when you deal with requirements, for example, there are some issues when you want to exchange the whole specification or individual requirements. I think it also has some limitations regarding synchronization between the integrated tools. And indeed, in the scope of task 5.1, KPIT has performed initial analysis of the limitations with OSLC. So that means that we should find ways to overcome them, or we should try to find alternative means in some cases for integration with external tools.
Okay, thank you.
Any other questions?
Yeah, no, I'm sorry if that was just answered because I struggled here with my mic. You mentioned that the modularity of the artifacts can go down to the level of requirements, and in some of the previous presentations there was a screenshot where we have seen on the left-hand side a list of parts of the standards, on the right-hand side the list of artifacts, and there was some relationship established between those two types of things. And I just wonder whether it can be sometimes practical to establish this relationship also down to the individual requirements, or whether it's just meaningful to define it
Yes,
to the level of art documents.
It depends, because sometimes you can have a document you will use as a whole as to map it to the standard, but other times you need to map parts of the documents.
And is there any automation, like inheritance of the relationships to the parts of what was defined?
No, in that case, the support was very basic, and we, for example, didn't support that you have inheritance. You will import some properties from the parent artifact, and that's actually somehow a limitation in OPENCOSS.
Okay, thank you.
So if no one else has,
I have this is Stefano from FBK. I have
okay.
one further question. A question general also for the previous presentation. Is there currently any support for automatically instantiating the argumentation and the artifact model? For example, in the MILS we worked on some patterns of argumentation in GSN that were automatically instantiated based on the model of the system architecture and the verification that we perform with some verification tools. So I would expect that maybe we can work on similar support also in AMASS, and the same probably can be applied also to the artifact model that can probably be automatically populated based on for example, the CHESS model and whatever verification has been applied on the CHESS model.
So for the artifact model itself, we didn't develop support for that. We did it for the argumentation. But I think that's an interesting area for AMASS, because indeed in the OpenG, in SCCM, it seems that the future versions will include this kind of artifact patterns.
One of the things related to this will be something like we do have the patterns, we do have argumentation, the solution, the solutions in argumentations linked to the artifact and the artifact model. So this connection is already done. I assume that when we have our system model, we will be able to create the contents of some evidences that will be part of the artifact model, and some information related there in the content will be part of the argumentation.
But I think this is clear, but it would be nice, useful, and I think it's a nice direction to work on in AMASS to automatically done this linking based on whatever is performed on the modeling and verification part.
Yeah. That's something we want to do.
Anything else? Okay, then I think we can now switch to the final presentation.
Hello, could you give us the presentation role? Okay. Okay, very quickly regarding the previous question about OSLC and the conclusions of OPENCOSS about OSLC, the partial conclusions were captured by Capit in the SVN folder. If you go to task 6.1, you will see there an Excel file and some of the conclusions from OPENCOSS, but also from Capit regarding the inconvenience of using OSLC can be found there. Okay. Regarding this presentation of cross-domain reuse, I already did this presentation to the task 6.1. So I will go very quickly. Some of the concepts were already presented also before. So this is about reuse, but reuse across application domains, okay, which was one of the goals in OPENCOSS. The case study we used in OPENCOSS for cross-domain reuse was Thales. So there were two Thales divisions, railway and avionics, which at some point follow some similar process, but when we go to software development for critical domain, and there are a lot of differences. So we try to find what are the common points in the OPENCOSS project and try to find how much we can reuse from the assurance and certification perspective. Okay, it was basically related to the reuse of execution platform. So it was basically based on DO178C standards, and this standard is not only okay, it's about software, but it's software running on a specific hardware platform. So we follow this standard to measure how much we can reuse from one application domain to another. And from the railway domain, it was Senelec 128. Okay, the goal was to find what are the correspondence between standards and to find how much we can reuse from these two standards. So we modeled the mapping equivalence as a first step. Then we found what are the reuse opportunities. So in our approach, we didn't automate the reuse, but we give to the users the opportunity to see what are the reuse opportunities, and then they to decide if they want to reuse. Okay. Okay, I will not go into detail, but regarding the previous diagram we show about equivalence models. So we have, for instance, two concepts in our models. Here, the PSAC, which is the certification plan for software development, and we have the PSAC in another domain. So we can map both concepts by specifying this equivalence map. So equivalence map is a justified partial or total equivalence between two assurance assets. This could be artifacts, activities, or any other asset in the process. Okay, so the first step was to conceptually define what are the equivalents between EN 5128 from railway for software development and DO178C from avionics. We found what are the common points for the objectives, for the artifacts and requirements, and we mapped both of this. So we created first in Excel the common parts between these two standards, how they map, if they are full mapping, contributory mapping, which is no map, or partial mapping. Okay. When we have this conceptual mapping, we take, in this picture you can see on the right side the DO17AC concept or asset. In the left side you can see the railway ones. So we have a concept here, for instance, two requirements from the DO17AC will map to one requirement in the railway standard. So we can then, when we check the points that map, we can justify this mapping. Okay, something that we wanted to do in OPENCOSS and we didn't really do is to structure this justification, because we found that we can provide this justification to see a lot of implications of the mapping. So this was not implemented, but conceptually we worked in this justification. We can also determine what are the post conditions. It means that we reuse something from one domain to another. If some requirements remains, that must be fulfilled in order to comply with the new standard. So if you are using a requirements document from railway and perhaps in avionics, a new artifact is required, which is a traceability of the requirements at different levels. So these kind of things can be specified here in the post conditions. So these reuse opportunities are something that can be used in different projects. Then when we go to the project, we saw those mappings we did in the previous steps, but for a specific project, and then we can create these assurance assets. Something that we automate in OPENCOSS is that when we are starting from scratch in an artifact model in avionics, we can create automatically a structure or a basic model of artifact by using the standard models. Perhaps this answer a little bit the previous question about automating something. So in this approach, we were able to, by using what the standard requires, we automated the creation of an artifact model. Of course, there are a lot of information that should be completed, but at least the structure of the information was automatically created. Okay, and then we were able to, when we want to reuse something from the railway domain, we can decide if we reuse it or not. Okay. Okay, this diagram is also related to one question from Morayo before, from CA. So we have our database from OPENCOSS. So here we are illustrating that we want to reuse it from railway project to avionics project in the database. So what we are reusing here is the information that we are maintaining in OPENCOSS. But the real artifacts or the resources, which could be modeled from the engineering side, are not really reused. This can be this is something that is managed separately, and it's something that we need to think more in the AMASS project. Okay, I think that's all. In summary, what we say is that in the first step we are able to map the concepts from one standard into another, and then we can provide this information to the users to decide if they want to reuse things that are mappings. So this could be artifact requirements or activities. Of course, there are a lot of work to be done regarding cross-domain reuse. This was an initial approach, and I guess that there are a lot of complementary work that we can do with the SafeCer project, which they also follow a more process-centered reuse approach. Okay. You have here some of the activities that must be done in the OPENCOSS tools in order to do the reuse. I will not explain the details, but all this information is in deliverable 2.4 in OPENCOSS. Okay, that's all for the cross-domain reuse. Sorry for going very quickly. The time we are delayed already, and as I did already this presentation for Work Package 6. Do you have any question right now about cross-domain reuse?
It just seems to me that the equivalence mapping kind of suggests that some transportation system should be developed that would be capable of flying, going by rails or by road at the and yeah, sorry. Kind of, you know.
Okay, any other comment or question? Okay, so if there is no more questions, we can close the meeting, or if you have more general questions about the OPENCOSS presentation, of course we will have the opportunity to discuss all these details in the work package, technical work package. No? Thank you very much to everybody.